Hi all, in this lecture we're going to talk about the paper written by Hubert Dreyfus entitled Why Heideggerian Artificial Intelligence Failed and How Fixing It Will Require Making It More Heideggerian. This paper was published in 2007 and includes Dreyfus' main criticisms against the project of artificial intelligence that he developed in his books What Computers Cannot Do, The Limits of Artificial Intelligence, and What Computers Still Cannot Do, A Critique of Artificial Reason. Symbolic Artificial Intelligence as a Degenerating Research Program. Dreyfus begins explaining that the insights formulated by the philosophers Heidegger and Merleau-Ponty were bad news for those working in artificial intelligence laboratories. But why? By combining representationalism, conceptualism, formalism, and logical atomism into a research program, artificial intelligence researchers had condemned their enterprise to reenact a failure. What are all these concepts? Representationalism. This is a school of thought that considers that the mind perceives only representations of material objects outside the mind. Conceptualism. This is the perspective that the intellect imposes a conceptual structure on reality. Formalism. This is the point of view that holds that all human knowledge can be expressed in formal propositions. And logical atomism. This is the school of thought that thinks that every proposition can be reduced to an elementary proposition that asserts the existence of atomic states of affairs. Researchers in artificial intelligence were running up against the problem of representing significance and relevance, a problem that Heidegger saw was implicit in Descartes' understanding of the world as a set of meaningless facts to which the mind assigned values. Remember that Descartes is one of the main philosophers who developed representationalism. Heidegger warned that values are just more meaningless facts. To say a hammer has the function hammering leaves out the defining relation of hammers to nails and other equipment, to a point of building things, to a skill required in actually using a hammer, all of which Heidegger called readiness to hand and that we studied at the beginning of this class. So attributing functions to brute facts could not capture the meaningful organization of the everyday world and so miss the way of being of equipment. The frame or relevance problem. Head of MIT's Artificial Intelligence Lab, Marvin Minsky, was convinced that representing a few million facts about objects including their functions would solve what had come to be called the common sense knowledge problem. It seemed to me, says Dreyfus, however, that the real problem was not storing millions of facts, it was knowing which facts were relevant in any given situation. One version of this relevance problem is called the frame problem. If the computer is running a representation of the current state of the world and something in the world changes, how does the program determine which of its represented facts can be assumed to have stayed the same, and which might have to be updated? Minsky suggested as a solution that the AI programmers could use descriptions of typical situations. He suggested a structure of essential futures and default assignments, a structure Husserl, the philosopher, had already proposed and called a frame. But a system of frames is not in a situation, so in order to identify the possibly relevant facts in the current situation, one will need a frame for recognizing that situation. It thus seemed to me obvious, says Dreyfus, that any AI program using frames was going to be caught in a regress of frames for recognizing relevant facts, and that therefore the common sense knowledge storage and retrieval problem was not just a problem, it was a sign that something was seriously wrong with the whole approach of artificial intelligence. What has always distinguished AI research from a science is its failure to face up to and learn from its failures, says Dreyfus in a very critical tone. John Hallam argues that symbolic AI has failed and refers to it as good old-fashioned AI. Michael Wheeler goes further, arguing that a new paradigm is already taking shape. He says, a Heideggerian cognitive science is emerging right now, in the laboratories and offices around the world where embodied embedded thinking is under active investigation and development. Based on the failure of symbolic AI that followed representationalism or good old-fashioned AI, there are currently three Heideggerian approaches to AI that accept Heidegger's critique of Cartesian internalist representationalism and instead embrace John Hallam's slogan that cognition is embedded and embodied. However, we will learn why Dreyfus thinks that all these three Heideggerian approaches to AI have failed. The first stage of Heideggerian artificial intelligence, eliminating representations by building behavior-based robots. In his book, What Computers Cannot Do, Dreyfus states that the meaningful objects among which we live are not a model of the world stored in our mind or brain. They are the world itself. Based on the idea that the best model of the world is the world itself, Rodney Brooks developed a different approach from good old-fashioned AI robots that use representations of the world, in which a mobile robot uses the world itself as its own representation, continually referring to its sensors rather than to an internal world model. Brooks' approach is an important advance, but his robots respond only to fixed features of the environment, not to context or changing significance. They are like ants, and Brooks aptly calls them animats. By operating in a fixed world and responding only to a small set of possibly relevant features that the receptors can pick up, Brooks' animats beg the question of changing relevance and so finesse rather than solve the frame problem. Merleau-Ponty's work, on the contrary, offers a non-representational account of the way the body and the world are coupled, that suggests a way of avoiding the frame problem. What the learner acquires through experience is not represented at all, but is presented to the learner as more and more finely discriminated situations. And if the situation does not clearly solicit a single response, or if the response does not produce a satisfactory result, the learner is led to further refine his discriminations, which in turn solicit more refined responses. Artificial intelligence researchers need to consider the possibility that embodied beings like us take as input energy from the physical universe, and respond in such a way as to open them to a world organized in terms of their needs, interests, and bodily capacities, without their minds needing to impose meaning on a meaningless given, as Minkey's frames require, nor their brains converting a stimulus input into reflex responses as in Brugge's animats. The second stage of Heideggerian AI, programming the ready-to-hand. Phil Agris and David Chapman's program Pengy guided a virtual agent playing a computer game called Pengo, in which the player and penguins kick large and deadly blocks of ice at each other. Agris' interesting new idea is that the world of the game in which the Pengy agent acts is made up not of present-at-hand objects with properties, but of possibilities for action that trigger appropriate responses from the agent. As Agris saw, Heidegger wants to get at something more basic than simply a class of objects defined by their use. At his best, Heidegger will, I think, says Dreyfus, deny that a hammer in a drawer has readiness to hand as its way of being. Rather, he sees that for the user, equipment is a solicitation to act, not an entity with a function future. In coping at my best, I'm not experiencing the door at all, but simply pressing into a possibility of going out. Agra's Heideggerian AI did not try to program this experiential aspect of being drawn in by an affordance. Rather, Agra objectified both the functions and their situational relevance for the agent. In Pengy, when a virtualized cube defined by its function is close to a virtual player, a rule dictates the response, for example, kick it. No skill is involved and no learning takes place. For Heidegger, the ready-to-hand is not a fixed function, encountering a predefined type of situation that triggers a predetermined response that either succeeds or fails. Rather, as we have begun to see and will soon see further, readiness to hand is experienced as a solicitation that calls forth a flexible response to the significance of the current situation, a response which is experienced as either improving the situation or making it worse. Agra doesn't even try to account for how our experience fits back and changes our sense of the significance of the next situation and what is relevant in it. Imputing his virtual agent in a virtual world where all possible relevance is determined beforehand, Agra doesn't account for how we learn to respond to new relevance, and so, like Brooks, he finesses rather than solves the frame problem. Pseudo-Heideggerian artificial intelligence, situated cognition, and embedded embodied extended mind. Michael Wheeler says, our global project requires a defense of action-oriented representation. Action-oriented representation may be interpreted as the subagential reflection of online practical problem-solving, as conceived by the Heideggerian phenomenologist. Embodied embedded cognitive science is implicitly a Heideggerian venture. For Dreyfus, Wheeler is looking in the wrong place. Merely in supposing that Heidegger is concerned with subagential problem-solving and action-oriented representations. Wheeler's project reflects not a step beyond Agri, but a regression to pre-Brooks' good old-fashioned artificial intelligence. Heidegger indeed claims that skillful coping is basic, but he's also clear that all coping takes place on the background coping he calls being in the world, which does not involve any form of representation at all. Being in the world is more basic than thinking and solving problems. It is not representational at all. That is, when we are coping at our best, we are drawn in by solicitations and respond directly to them, so that the distinction between us and our equipment vanishes. In our most basic way of being, that is, as skillful copers, we are not minds at all, but one with the world. What motivates embedded embodied coping? An organism, animal or human, interacts with what is, objectively speaking, the meaningless physical universe in such a way as to experience it as an environment organized in terms of what that organism needs in order to find its way around. All such coping beings are motivated to get a more and more refined and secure sense of their environment and of the specific objects of their dealings. My body is geared into a world when my perception presents me with a spectacle as varied and as clearly articulated as possible. Walter Freeman's Heideggerian Merleau-Pontian Neurodynamics. In another paper that you have not read, Dreyfus explains that the intentional arc is the tight connection between the agent and the world. That is to say that as the agent acquires skills, these skills are stored, not as representations in the mind, but as more and more refined disposition to respond to more and more refined perceptions of the current situation. Freeman provides a model of how the brain could provide the causal basis for the intentional arc. Freeman takes seriously the idea of the brain as a nonlinear dynamical system, and has worked out an account of how the brain of an active animal can find and augment significance in its world. Each learning experience that is significant in a new way sets up a new attractor and rearranges all the other attractor basins in the landscape. Brain activity patterns are constantly evolving, reforming, and changing, particularly in relation to one another. When an animal learns to respond to a new odor, there is a shift in all other patterns, even if they are not directly involved with the learning. There are no fixed representations, as there are in good old-fashioned AI computers. There are only significances. Each time a new significance is encountered, the whole perceptual world of the animal changes, so that significance, as directly displayed, is contextual, global, and continually enriched. Freeman has actually programmed his model of the brain as a dynamic physical system, and so claims to have shown what the brain is doing to provide the material substrate for Heidegger's and Merleau-Ponty's phenomenological account of everyday perception and action. How will Heideggerian artificial intelligence dissolve the frame problem? Heidegger and Merleau-Ponty argue that thanks to our embodied coping and the intentional arc it makes possible, our skill in directly sensing and responding to relevant changes in the world is constantly improved. As I cope with a familiar task in a specific situation, other situations that have in the past been relevant are right now present on the horizon of my experience, summoning my attention as potentially, not merely possibly, relevant to the current situation. Dreyfus concludes by saying that to program Heideggerian artificial intelligence, we will have to include in our program a model of a body very much like ours, with our needs, desires, pleasure, pains, ways of moving, cultural background, and so on. If we cannot make our brain model responsive to the significance in the environment as it shows up specifically for human beings, the project of developing an embedded and embodied Heideggerian AI cannot get off the ground. Even if the Heideggerian Merleau-Pontian approach to AI suggested by Freeman is ontologically sound in a way that good old-fashioned AI and the subsequent supposedly Heideggerian models proposed by Brooks, Agra, and Wheeler are not, a neurodynamic computer model will still have to be given a detailed description of our body and motivation like ours if things were to count as significant for it so that it could learn to act intelligently in our world. The idea of supercomputers containing detailed models of human bodies and brains does not have a chance of being realized in the real world. That is all for today. The next reading about AI by Ragnar Phelan is much more clear and accessible than this one. I hope you enjoyed that reading entitled Why General Artificial Intelligence Will Not Be Realized.